So start with something basic here, something that's maybe more familiar, and they'll get to the a little more complex stuff, okay, when it comes to simplifying. All right, so the square root of 72, right? Is 72 a perfect square? It is not, right? 72 is not a perfect square. So we can't just like straight up simplify it into some like nice number, right? Instead, we look for perfect squares that divide 72. So can anyone think of a perfect square that divides 72? Four? Let's try 4. Okay, I hear 4 from Braylon there. 4. So let's try it. So yes, 4 is a number there. So 72 is, I got it. 18? 18, yeah, okay. So 72 is root 4 times 18, right? So when I have root 72, I could equivalently write the square root of 4 times 18. And then the property that we have with square roots is that you can break a square root up over multiplication or division, right? If this was a plus sign, I would not be able to break this up. But since it's multiplication here, I can say this is the same thing as saying root 4 times root 18, okay? And this is what we've done in the past, right? And we're like, oh, okay, square root of 4, what is that? It's 2, and then we have the square root of 18 here. And then we go back to this 18. Are there any perfect squares that divide 18? There are some. There's one. 9 and 2. Yep, 9 and 2. So we have 2 root 9 times 2, like this, right? So I still have the 2 in front from that 4, but then the root 18 I'm also breaking down to 9 times 2, which will be then 2 root 9 root 2, just like that. Okay. And what is the square root of 9? 3. So we'll have 3, but then we still have this 2 in front too, right? So it's 3 times 2, which gives us 6 square roots of 2. And then can I divide 2 by any other perfect squares? Besides 1, right? But 1's not going to simplify it down. And so there's the simplified version of the square root of 72. Okay. So there's a simplified version of the square root of 72, right? So in other words, right, root 72, not a perfect square, but we're able to simplify it down so that we have some whole number part outside and then like a square root still with the leftovers that didn't have any perfect squares, right? That no more perfect squares. So we'll have like, you know, some stuff that's simplified and then some stuff that still remains unsimplified because we just couldn't simplify any further. And that's what we're going to be looking at today, right? We already have this idea in our head that, you know, there's situations where we'll have some things that do pull out of the square root, right? That we can kind of take out of the square root or any root, and then we're left with some leftovers, though, in this case, right? So let's do one more just to make sure we're okay with this. I think I had an example that I wanted to do. Yep. All right, let's... Now, we didn't do too much with cube roots yet, but we can do it with cube roots too, or any other roots that we want to. Okay? So now let's talk about the cube root of 48. Is 48 a perfect cube? It's not, right? It's a perfect cube of something, but not of a nice number, right? So it's not a perfect cube, right? Are there any perfect cubes that divide 48 evenly? So here we have to think about our perfect cubes, right? So what is a perfect cube? There is one. There's a perfect cube that divides 48. So what would it be? (16) is not a perfect cube. It does divide 48, though. Yes, it's a perfect square. But here, remember, since we're doing the cube root, we're looking for perfect cubes. So, like, think about your perfect cubes. 1 is a perfect cube. 0 is a perfect cube. 8 is a perfect cube. 27 is a perfect cube. Any of those divide 48 evenly? 8. 8 does, right. So we can rewrite this cube root of 48 as the cube root of 8 times 6, right, which is then just the cube root of 8 times the cube root of 6. And what is the cube root of 8? 2. It's 2. So we get 2 cube root of 6. And there's our final answer, because there's no more perfect cubes that are going to simplify that 6 any further, right? You can't divide 6 by another 8. There's no other perfect cubes that divide 6, except for 1. But again, 1's not going to reduce it at all. Okay? So in this case, right, these two were similar, except we just had to be a little bit careful, right? We were square rooting here, so we looked for square roots that we could kind of, divide this up into and then square root. Here is a cube root, so we're looking for perfect cubes, right? And of course, if I did a fourth root, then I'd be looking for perfect I don't know what you call them, but things to the fourth power. And if it was the fifth root, then you look for things to the fifth power and stuff like that. Okay? So let's jump in here then to a problem like, let's throw in some variables now. Okay, and let's do the fourth root of 2x to the 6th y to the 8th. Okay. Now, when it comes to variables here, I'll show you two ways. One way is we can kind of do it like we did right here, okay, or like here. Okay, so we can use this idea that we did right here to then simplify something like this. All right, so let me show you what I mean. So we could break this up and say, okay, fourth root of 2 times the fourth root of x to the 6th times the fourth root of x to the 8th. Okay? Now, 2 is not going to break down any further, right? 2 is prime, so unfortunately that 2 is going to stay the way that it is. Okay, 2 does not break down any further. But x to the 6th, I could rewrite that as a power of 4, right? This is the same as x to the 4th times x to the 2nd, right? Isn't this the same thing? Okay, x to the 4th times x to the 2 would give me back to that x to the 6th there. So this is okay to break that up. Now, why did I break it up this way? Why didn't I say x to the 3rd times x to the 3rd, for example? I could have said that. Why did I say x to the 4th times x squared here? Any ideas? What kind of root are we trying to do here? It's a fourth root, right? And so I want to break down my x to the 6th into 4s, you know, like, so x to the 4th here. So that way this will simplify, right? Because I have a fourth root and I have x to the 4th there. Likewise here, okay, this x to the 8th, wait a minute, it's y to the 8th. Sorry, I was like, why do I have two of the same variables there? Y to the 8th, I can break that down to be y to the 4th times y to the 4th, right? Again, I could break down y to the 8th. I can make it y to the 3rd and y to the 5th. Or I can make it y to the 2 and y to the 6th. Or y to the 1 and y to the 7. But we choose y to the 4th here because, again, we're taking the fourth root. Okay? So, the fourth root of 2 stays the fourth root of 2. We can't simplify that. But I can break up this one. And I can break up this one here as well. Okay. So, fourth root of 2 is going to stay that same way. What's the fourth root of x to the 4th going to be, though? What does this simplify to be? Just x, right? It's the fourth root of x to the 4th, so it simplifies just to x, right? And then this one right here, we'll have to leave it because we can't take the fourth root of x squared there. What's the fourth root of y to the 4th going to be? The fourth root of y to the 4th. What will that simplify to be? We have a perfect, it's like it's y to the 4th, right? And we take the fourth root of it. It's just y, yeah, it's just y. And then what about this one? This one will also be y as well. Okay? So you'll see, right, that we have some things that simplified down nicely and we got rid of the root, right? Those simplified to there and there. But then some other things we couldn't simplify, right? That x squared, the fourth root of x squared, we just can't simplify that because, there's not enough x's there for us to take the fourth root of it. Same thing here, the fourth root of 2, we can't break that down any further, so it just stays the way it is. So now we'll collect all of our numbers, all of our variables here that are no longer underneath a root. We'll put those in front, so it becomes x, and then y times y simplifies to what? Y to the 2nd, yeah. So xy squared, and then everything that's underneath the root will recollect together again as well. And so there's our final answer. Okay, there's our final answer. So again, what did we start with? We started with this problem right here, right? Everything underneath the fourth root here, okay? We broke up our three pieces underneath the fourth root, and then we broke further up into things that were raised to the 4th and the rest, right? And here y to the 8th, both we could say were y to the fourth there. And then we broke those up and simplified the ones we could, right? So this one simplified, and this one simplified, right? To these right here. And we had our leftovers then that we recollected. Okay. That's one option for simplifying problems like this. Okay, that's one option. Okay, that's one option. Oop. Okay. So questions on any of that? No siree, Bob? Okay. Let's take a look at another way. And you guys kind of make a decision about which one you like here, because I'm not really sure which one I like more. So we'll do the same problem here. Okay, I keep making it worse. Rewrite it. There you go. Okay, so this is one way to do it. It's more like how we simplified things in the past with like simplifying square roots and stuff like that. The other way we could simplify this is using our rational exponents. So for example, a fourth root is the same as what exponent? The fourth root of something is the same as what exponent? 1/4, right? So I could rewrite this as the quantity 2x to the 6th, y to the 8th, raised to the 1/4 power, like that. Whoops, off the screen, there we go. Okay? So I could rewrite it this way. Okay? And now I can distribute that power, right? So this becomes 2 to the 1/4, x to the 6th to the 1/4, y to the 8th to the 1/4. Okay, like that. Okay. 2 to the 1/4, there's nothing else I can do with that for right now, so I'll leave it 2 to the 1/4. X to the 6th to the 1/4, when we have a power raised to a power, what do we do with our exponents? We have a power raised to a power, what do we do with our exponents here? Multiply. So this is really 6 over 1, right? So it's 6 over 4. X to the 6 over 4. Okay? And then here, okay, here we'll have 8 over 1 to the 1 over 4. So again, we'll multiply the exponents there. We get y to the 8/4. Okay? So again, 2 to the 1/4, we can't really divide that anymore. It's just going to be 2 to the 1/4 there. We're going to have to leave it that way. Okay, but this 6/4, right, we can actually kind of divide that, right? So you could see it as a fraction, okay, but I'm actually going to leave the denominator here the same because I want to try and keep it all the same root. So instead what I'm going to do is I'm going to do 6 divided by 4. Okay? And I get 1.5. All right, 1.5. So that fraction 6/4, let me see if I get it. There we go, all fit. Gives me 1.5 as an answer here. So in other words, I have x to the 1. Well, let me see if how can I do this? Maybe I don't know if I want to do it that way. That's helpful. So you can see that there's 1/4 that goes in there, and then another half of a fourth there. That's not super helpful, I don't think either. Let's break the fraction up into this, right? 6/4 is the same as 4/4 and a 2/4, right? And I break it up here so that way I have a nice, these will cancel nicely. I have 1, right? I'm trying to get one whole here, okay? But then I have the leftover, the 2/4. And then for this one, the 8/4, we can break it up into 4/4 and 4/4 as well. Okay, so that 8/4 is 4/4 and 4/4 there. Okay, what we're trying to do is create one whole here, one whole, right? That's 6/4, we break it up so we have a 4/4 and a 2/4. That 4/4 will become a 1. So x to the 1, we still have an x to the 2/4, and then this becomes a y to the 1, and this becomes a y to the 1. Okay, you're noticing x, y, y. So there's our x, y squared there. So I'm going to recollect those out front, right? The x, the y, and the y all go out front there. And I'll rewrite these 2 to the 1/4, x to the 2/4. Okay? And since these are both still to the fourth power, I can rewrite those like that. Did I just do some mathemagic there? Okay. Questions on any of that? Yep. Yeah. So again, we rewrote that fourth root as a 1/4 power and then distributed it, right? And then we simplified here. We had power to a power, so we multiplied. Power to a power, so we multiplied. Got 8/4. Then once you get these fraction exponents, okay, you break up those exponents so that you get, you're trying to create like one whole there, right? So 4/4 and 2/4, right? And then here for the 8/4, we can break that into 4/4 and 4/4. Simplify the wholes, right? So 4/4 is 1, 4/4 is 1, 4/4 is 1, okay? And then we have the leftovers, the remainders there, the 2/4, right? Collect all of the ones that, simplified nicely there, and then the fourths we recollect as well and put them underneath the fourth root and make it just 2 and then x to the 2, like that. So I don't know. It's really your choice about here which one you think is more preferable, I guess. I'm going to guess maybe this is more comfortable for you guys. I'm not sure. All right. Both of them are complex, okay? They're not easy, right? I get that. Let's do another one, though, and see how we do. Okay? I can do it either way, whichever way you guys would prefer to see it. So we can do it either way here. Ugh. Okay, let's do a square root one. Okay, let's do a square root one. Okay, so again, it's your choice here. We could leave this as to the 1/2 and then distribute the power to each one. That's going to simplify it like this one right here. So I'll do that way first. So let's see, I'll kind of like divide it up again, and I'll put it over here. So we can start with, for example, 256 to the 1/2 power times x to the 3rd to the 1/2 power times y to the 7th to the 1/2 power. Okay, I'm just going to zoom in on this one right here. Okay, is 256 a perfect square? It is. It's 16 squared. Okay, so this simplifies down to 16 here. But then x to the 3rd to the 1/2 becomes x to the 3/2, and x to the 7 to the 1/2 becomes x to the 7/2. Why? Why do I keep doing that? There you go. Okay. That. All right. Remember, we're looking for ones here that we can make. We want to create ones. So 3/2 becomes x to the 2/2 times x to the 1/2, right? So I break up that 3/2 into 2/2 times 1/2, right? And then here for this one, the 7/2, well, that's y to the 2/2, and then another y to the 2/2, and then another y to the 2/2, and then y to the 7, or 1/2, I should say, right? 2, 2, 2, and then 1. I could make it 6/2 and 1 if you like, but yeah. Again, we're looking to create whole numbers here, right? One whole. You could, if you wanted to, bathroom. Yeah. Why don't we finish this one and let you go? All right. You could instead make that y to the 7/2. You can make it y to the 6/2 times y to the 1/2, like that. So 7/2 is 6/2 and 1/2 again. The 6/2 is about 3. It's kind of your choice, though. I mean, there's lots of options here, and that's what makes these kind of difficult, because there's lots of different options you could do. Okay. So x to the 2/2 is x to the 1 there. Then we still have the times x to the 1/2. This is a y to the 1 times another y to the 1 times another y to the 1. And then we have y to the 1/2. Okay. Just get all these simplified down to just y there, right? Whoop. And then we'll collect all of the whole number terms. So we'll have a 16, we'll have an x, and we'll have 3y, so that's y to the third. And then the x to the 1/2 and y to the 1/2, well, they'll still be underneath a square root, like that. Okay? And so there's our final answer. Okay. Again, I'm not really sure I'm sold on that method, but that is one way to do it. I'm not sure I'm sold. I'll show you the other way here in just a sec. To simplify. Okay. So, the other way then would be to change this 1/2 exponent to what root? So, yeah, AJ, if you want to go ahead. All right, the other option here, if you want to go ahead, AJ, sorry. If the other option here is to change this 1/2 exponent to what root? If you raise something to the 1/2, it's the same thing as what root?
2.
The square root, yeah, 2. Okay, so we can also then just rewrite this as the square root of 256 x to the third y to the 7th. Okay, and then we can say, all right, well, this is the square root of 256 times the square root of x to the third times the square root of y to the 7th. Okay, and then we can, again, 256 is a perfect square. It simplifies to just 16. The square root of x cubed, I'm going to rewrite as the square root of x squared times x to the 1. I'm going to zoom in on this one here, sorry. Okay, and then the y to the 7th, I'll rewrite that as the square root of, I guess I'll make a bunch of perfect squares there. Okay. Y to the 7th is y squared times y squared times y squared times y to the 1, right? 2, 2, 2, 1. And the square root of that x squared will give us just an x. We'll still have an x left underneath. And then y, so y to the third, and then square root of y. And so we write the whole thing there, 16xy to the third, and the square root of xy. Again, you can put those x's and y's back underneath the square root there to simplify it. Again, it's really your choice about what you're most comfortable with, right? Okay, so it's really your choice about what you're most comfortable with. Okay. Those y squareds there, y squareds all become 3y, 3y's multiplied together, so y cubed. Okay, and then the x squared became that x right there, right? So, your choice. We do get the same answer. Okay. All right, so let me give you one to try here and see what you can come up with. So here, you guys try this one here real quick. I won't give you something as complex as this one to start out here. Or actually, no, this is for you guys to try. So here, try this one. Let's do the 4th root of 16 times x to the 14. And let's also have you do the square root of 18 x to the 5th. Okay. So try and just simplify those as best you can. Again, I'll leave this one up here to maybe show you. I don't know. Okay. So simplify those as best you can. Simplify them as best you can. Okay. See what you can do there. Try and simplify those as best you can. So again, look for that first one. Make sure you're looking for a perfect. Shh, Jason, let's get started now. All right, 4th root here. All right, looking for perfect 4th power of things, and then here, square root. Looking for perfect squares here. All right, look for perfect squares. right? So, let's see what you can come up with here. And then after this, we'll get into something a little more comfortable, I think. Hopefully. See what you can do. See what you can do. Questions, let me know. Okay, what did you do so far? So you can do 16 to the 1/4 with your calculator, right? And then for here, right, you look to see how many times does 4 go into that 14? Okay, how many fourths? Break that up to be. Michael, do you have a question? Sorry.
Oh, no,
You're good. So that 14 fourths, right? That's the same thing as x to the 4 fourths. Right, so 4, that's 12. And I can make 14. So that's going to be. Break up that 14 fourths to be this, right? 4 plus 4 plus 4, that'd be 12, and then that makes 16. Sorry, 14. And these all would be. And this would be like, wow. Does this make sense? So that's what you want to do with your fraction there. Okay. I know. Yeah. Square roots are tough enough, then you start throwing fractions. It makes it more difficult. Yes. It's x to the 14th. 16 times x to the 14th. Okay, so saw a lot of blank papers. All right, so we'll go over this one here. All right, this is not easy, right? This is not easy, and I think part of the reason why it's not easy, again, we're working with fractions. There's no like one super nice, easy, clean way that always works every time. It kind of really depends, I guess. But again, when you're taking the fourth root, okay, you can break up, so like this, right? Okay, you can break up that fourth root over the 16 and the x to the 14th there, okay? So you can actually just you can just do the fourth root of 16 if you want to. I mean, that is just 2, right? 16 is 2 to the fourth. So this is literally simplifies down just to 2 there. And then here for this one, well, again, to take a fourth root, you need to have x to the fourth in here. Well, 14, I could rewrite that as x to the fourth times x to the fourth times x to the fourth. That's 12 now, right? 4, 4, 4 is 12. And so that means I need 2 more, so x to the second. Okay? And so what's the fourth root of x to the fourth going to be? What's the fourth root of x to the fourth going to be? Just x, right? And so I could say, okay, so this will become just x. This will become just x. This will also become just an x. And then can I take the fourth root of x squared? No, right? So we're going to leave that underneath the symbol, underneath the fourth root there. Okay? Like that. And so we end up with 2x to the third times the fourth root of x squared. Okay? Like so. Now I can also show it with rational exponents. Does anyone want me to show it with rational exponents? That is when you have a fraction for an exponent. Anyone want me to do it with that? We're all good? Tatum, you did it that way. Did you want me to show it that way? Are you okay? Okay. All right, next one here, square root of 18x to the fifth. All right, same idea, except 18, if I break it up here, is not a perfect square, nor is x to the fifth, right? So it won't simplify super quickly, but I can take 18 and make it root 9 times root 2, right? And then x to the fifth, I can rewrite that as x to the 2 times x to the 2 times x to the 1, right? 2, 2, and 1. Square root of 9 is 3. And then the square root of x, again, this will simplify down just to x. That simplifies down just to x. And then I'll have the square root of x left over. X to the 1, if you like. Okay? And so the 3, the x, and the x together make 3x squared. And then the root 2 can go in there with the root x. I'll make it root 2x. And there is our simplified answer. Okay? Questions on any of that? All right. I did also want that, so we'll move on from that for today. We'll do a little more practice with that tomorrow, I think. Excuse me, in preparation for the quest. Yeah, okay. So what we'll do is then also I want to talk about solving radical equations. Okay, cowabunga. Here we go. Okay, so in other words, solving equations now, okay? Solving equations now with radical symbols in them, right? So it could be square roots, cube roots, fourth roots, fifth roots, whatever root you like. We'll start with some basic ones today, and then I might show you a few more tomorrow, okay? In preparation for that quest on Wednesday. All right, so let's do one here that's not too awful. Hopefully. Okay. So, here's our equation. Now, you guys already know how to solve this without me showing you how to do it, okay? Because we have these, right? How can we use our graphing calculators to solve this equation without us having to actually show work and stuff like that? What could we do? How do we type it in? Where we put it to solve an equation? Remember, anytime you want to solve an equation, you could do what? Graph it. Graph the left-hand side, graph the right-hand side, and then you're looking for where they what? Intersect, right? The x-coordinate where they intersect. Exactly right. So I mean, we could here, if we wanted to, we can go ahead and just figure out this answer without actually solving it. Square root x minus 3, and I'll graph the 2, okay? And let's see here. There's the square root x minus 3. There's 2, and I can see the point of intersection there, so I'll do second trace intersect, and let's see here. I got to find my curve. There it is. Okay. Enter, enter, and I'll go for the guess to make sure I'm close to that intersection point. And there it is, 7, 2. So my answer is x equals 7. Right? I'm sorry, you can see it better if I show it up there. X is 7. Right? There's my answer. So we know what the answer is, but let's see how we can actually solve this here. Okay. Any ideas? Because again, when we solve an equation, right, we want to get the x by itself. So any ideas here to start getting that x by itself? What could we do here? How can we get rid of that square root? What should we do? Square both sides. Yeah, so we'll square both sides. Okay. When I square a square root, I'm left with just x minus 3 over here. It exactly cancels. Okay. And then what's 2 squared? 4. Okay. And now what do I do to solve? Add 3 to both sides. Very good, class. Okay. X is 7. Okay. Now we need to be careful here because in this unit, right, we're trying to keep it real. So in other words, if I have an x value of 7, all right, I got to plug it back in to check. And I know you guys, right, you're probably told since like we first started solving equations, you should always check your answers. And none of you check your answers. And that's fine, okay? But you can, and you need to here, because sometimes your answer will not work, right? Sometimes you're going to plug your answer in here, and you'll end up taking the square root of a negative number, which is imaginary, and it won't equal this. So you do have to check your answers, but if I plug it in, 7 minus 3 is 4. What's the square root of 4? 2. And there it is, 2. We get the 2 that we wanted. Okay, so pretty straightforward there. Okay, the key thing you want to do here is isolate the radical, okay, expression. This is the key step you want to remember for solving these equations. Isolate the radical expression. Here it was already isolated, right? The square root was by itself. There wasn't any other junk with it. So we could then eliminate. Eliminate the radical using an exponent. Okay, let's do another one. Let me see here. I want to do something that's too off. Actually, yeah, let's do this one. It's not too bad. Excuse me. Okay, so here I got these to the 1/2 powers. I'm going to rewrite these, right? Anytime you have something to the 1/2, we can rewrite that as what kind of root? Square root. So I'll write root x plus 6 minus root 2x minus 4. Okay. Can I combine these two square roots together? We cannot, actually. We cannot. Okay. Subtraction here, we can't actually subtract these. Okay. They're not like, right? This is a root x plus 6. This is a root 2x minus 4. So I can't subtract. They're not like terms. So we have to leave them, you know, kind of like separate like this. Okay. But we're still going to isolate these square roots, right? Because right now they're not by themselves, right? This square root is with this square root, and this square root is with this square root. So I have to isolate them. How can I get one of these by themselves? What could I do in this situation here? What should I do to both sides? To isolate the square roots, to get them by themselves. Yeah, we're going to take this one and add it over. So we're going to add a square root of 2x minus 4, this whole quantity, we're going to add it to both sides. Whoops. And so I get root x plus 6 equals root 2x minus 4. Okay? So we're adding it over, and now they're isolated, right? Isolated by themselves. And what are we supposed to do here to eliminate these square roots? Now that they're isolated, what should we do to both sides? Square both sides. Okay? What does the left side simplify to be? X plus 6. Okay, what's the right side simplify to be? 2x minus 4. And then you guys can solve from here, right? Well, subtract an x on both sides. 2x take away an x is an x, minus 4. We'll add 4 to both sides, and we get x equals 10. Okay, x equals 10 is our answer. Let's check it, right? What's 10 plus 6? 16. What's the square root of 16? 4. Okay. What's 2 times 10? 20. Take away 4. What's the square root of 16? So we have 4 minus 4. Is that 0? Yes, it is. So 10 works. Okay, 10 works. All right. Let's do one more here, and then I'll get you guys started on your assignment. Uno más. Sure. If you feel like you're doing okay on this stuff, yeah, go ahead. All right, uno más. Let's change it up a little bit here. Ooh, cube. Oops, I'm messing up here already. It's a cube root. That's supposed to be a 2. Okay, the cube root. I'm just going to. Cube root of x plus 2 plus 7 equals 5. Okay. So again, we want to isolate the radical here. So what's with the radical that we need to get rid of? The 7, right? It's outside the radical, right? You can see the bar does not extend over top of it. If the bar extended over the entire side there, then you could add the 2 and the 7 together. But since the bar does not extend, right, that plus 7 is on the outside, we're going to subtract 7 on both sides to get that radical by itself. And so 5 minus 7 is negative 2. Okay. And then, to eliminate a cube root, what are we going to do to both sides? Cube it. And then we'll cube the right-hand side as well. What does the left-hand side simplify to be? X plus 2, right? And what's the right-hand side simplify to be? What's negative 2 times negative 2 times negative 2? Negative 8. Now you just subtract 2 from both sides. Get that x by itself. X equals negative 10. Okay? And you can check your work if you need to there. Negative 10 plus 2 is negative 8. The cube root of negative 8 is negative 2. Negative 2 plus 7 is 5. So check it works. And of course, you can always check yourself with a calculator too, right? You can graph the left-hand side, graph the right-hand side, find the point of intersection. You want the x-coordinate for that point of intersection, and then go from there. Okay. Questions on any of that? All right. So I'll give you guys the last 10 minutes here to get started on your assignment. I'll give you 1 or 2 problems like the earlier stuff we did, and then I'll give you a couple problems here like these, okay, for the equations to solve. Both topics will show up on Wednesday's, quiz test, okay, quest. All right, so understand that. So, like I said, I'll give you a few from 11.2, but then I'll also give you a few from 11-3 as well, okay? So, get that. So let's see here, 11-2. So page 397, number 14, and well, actually, I'm going to have to do 12 and 14. Sorry, 12 and 14 there. Okay, and then 11.3. Okay, on page 407. We kind of choosy here, so let me see. So we'll say 1, 2, 9, and 10. Okay. Ooh, I can't resist this one. 14. Okay. There you go. I gave some very straightforward ones there, I think, so it should be pretty quick. So there you go. 2 sections. All right. And then to our new guys here, I can get you some things, because it's a different book than I think that Mr. Walker was using.